GPU ownership versus API costs, the hidden math. The perennial question for any company building LLM-powered products, should you buy GPUs, rent cloud compute, or just pay for API calls, sparked a lively and revealing debate on Reddit's local Lame community. A developer planning to serve a few thousand users, with 24/7 traffic and around 256 requests per minute, initially estimated that API token costs grow very fast at scale, and that AWS rentals would reach full hardware price within a year, making ownership seem like the obvious winner. The community promptly delivered a reality check. Running a state-of-the-art model like DeepSeek v3.2 at full precision with adequate throughput requires server hardware worth easily $100 or more, one commenter noted. While someone suggested a configuration of 8X RTX 6000 Pro 96GB GPUs for around $80 total, others questioned whether consumer-grade cards could handle the load without datacenter-oriented H200 or H200 GPUs, and flagged that latency in terms of time to first token would be a nightmare for direct user interaction. The expertise gap emerged as a crucial factor. One commenter bluntly advised, "If this is a question you're asking, you're much better off paying for a managed API. You don't want to be learning about how to scale LLM inference on your own hardware while in production. Setting up robust inference infrastructure could take a year, and hiring qualified personnel is challenging due to rare specialized skills." Hidden costs, engineering talent, maintenance, security, operational overhead, and experimentation when new models release are frequently underestimated. The recommended middle ground: ensure any solution follows OpenAI API compatibility, enabling future migration to self-hosted solutions with minimal code changes. Market dynamics add another wrinkle. With AI companies building their own backyard nuclear reactors, current API pricing may be artificially low due to massive infrastructure investments and competitive pressure, suggesting APIs will remain cheaper until monopoly is established. The original poster eventually acknowledged being completely wrong in their initial calculations, but found self-hosting still made sense for their EU-based operation due to data sovereignty requirements limiting provider options. Cascade agents, smarter model routing. One creative solution to the cost versus capability trade-off comes from a new open-source library called Cascade Flow. The project addresses a common frustration. We were tired of guessing which local model to use for which query. The approach is elegant. Start with the smallest model, validate whether the output is usable, and only escalate to larger models when necessary. In practice, the developers report that 60 to 70% of queries never leave the small model. Benchmarking on GSM 8K math problems showed 93.6% accuracy, with cost dropping from $3.43 to $23, a 93% cost reduction for roughly 2% accuracy loss compared to calling cloud models for everything. The validation system runs multi-dimensional checks, including length, confidence via log probs, format, and semantic alignment. If any check fails, the query bumps to the next tier. User still gets a good response, just costs more for that query, the developer explained. Community feedback was enthusiastic, with one commenter offering detailed suggestions for making the escalation gate task-aware and compute-aware, using SymPy verification for math, requiring tests to pass for code, and tying escalation to node load to avoid overwhelming big model queues. SmallEvals, tiny models for RAG evaluation. Evaluating retrieval augmented generation. Systems typically requires expensive API calls to generate golden datasets. A new project called SmallEvals aims to change that with a 0.6b parameter model specifically trained to evaluate vector databases and retrieval pipelines entirely offline. The approach is clever. The QAG 0.6b model generates one question per document chunk, then measures whether your vector database can retrieve the correct chunk back using that question. This directly evaluates retrieval quality using precision, recall, MRR, and hit rate at the chunk level without needing cloud API calls. The system includes a built-in local dashboard for visualizing rank distributions, failing chunks, and retrieval performance. The key insight is that generated questions need to be specific enough to test retrieval meaningfully. It shouldn't be who is mentioned in the passage. Rather, it should be when was Marie Curie nominated to Nobel, the developer explained. Generic questions won't stress test your retrieval pipeline. Future models in the pipeline will evaluate context relevance, faithfulness, groundedness, and answer correctness, closing the gap for fully local end-to-end RAG evaluation. Local AI for photo workflows. Street photographer Nick has released Fixer, an open-source tool that uses the Qwen 2.5 VL vision model through Llama to automatically analyze, tag, rename, and organize raw photo files entirely offline. The tool runs as a Python terminal user interface and processes photos through AI-powered viewing to generate descriptive names like Golden Hour, Street, Portrait, Brick Alley, rather than generic object detection tags. On an M4 MacBook Air, 150 photos take approximately 13 minutes for complete processing, including burst stacking, quality culling, AI renaming, and keyword folder organization. Hash verification ensures file integrity, important for professional workflows where you can't afford to mess this up. Version 1.1 added a dry run protocol that simulates the entire sorting workflow without modifying files, plus a phantom cache that lets users execute cached AI decisions without reprocessing through the LLM. The project explicitly differentiates itself from server-based solutions like Image. Fixer processes your shoot, cull 5,000 raw, 50 heroes with AI names. Then those heroes get backed up to Image for long-term storage sharing. Different tools for different stages of the workflow. The roadmap includes EXIF-based auto-organization, GPS location sorting, and eventually face recognition. QA, local computer agent for 8 GB VRAM. A French developer has released a local open-source computer agent that runs entirely on 8 GB VRAM using Qwen models. The architecture handles both simple actions, open an application, lower volume, and complex multi-step tasks, browse the internet, create files with retrieved data, through an orchestrator that verifies each action completes properly. For web actions, the system first attempts playwright automation, which handles 80% of cases. When that fails, CUA vision kicks in. Take a screenshot, have a vision language model suggest what to do, run object detection via YOLO and Florence plus Paddle OCR, annotate detected elements on the screenshot, have a second VLM identify which element to click, then execute via PyAuto GUI. The loop continues until the task completes. The developer estimates the system can solve 80 to 90% of the tasks we can perform on a computer and is soliciting community improvements. OVHcloud joins Hugging Face inference providers. OVHcloud has become a supported inference provider on Hugging Face Hub, offering serverless access to models like GPT-OS Qwen 3, DeepSeek R1, and Llama with competitive pay-per-token pricing starting at 4 cents per million tokens. The integration supports 2 modes, using your own OVHcloud API key directly or routing through Hugging Face with charges applied to your HF account. The service runs on European data centers, relevant for users with data sovereignty requirements, and delivers sub-200 milliseconds response times for first tokens. Pro users get $2 worth of inference credits monthly that can be used across providers. Windows 10 Holdouts. A security time bomb. Dell's earnings call revealed a staggering statistic. Roughly 1 billion Windows users face security risks as Windows 10 approaches end of support. Of those, 500 million have older devices ineligible for Windows 11, but another 500 million can upgrade and have simply refused. Microsoft's sudden U-turn offering extended security updates free to home users until October 2026 may have backfired, creating a messy landscape with no public data on how many PCs running Windows 10, home or enterprise, are enrolled for ongoing updates and how many are already at risk from cyber attacks. The article argues that ESU should have been limited to users with older PCs, while others should have been mandated to upgrade. Related security concerns emerged around Notepad++, with small numbers of users reporting security woes, according to security researcher Kevin Beaumont's Double Pulsar blog. PIO and DMA without CPU. For embedded systems enthusiasts, a detailed tutorial on using programmed I/O and direct memory access (DMA) on the Raspberry Pi RP2350 microcontroller shows how to serve data without any CPU intervention. PIO lets you configure tiny state machines to process I/O logic independently from main code. essentially writing very simple programs to do very fast and efficient I/O. The feature present in both the original RP2040 Pico and newer RP2350 Pico 2 is being used in the VRAM project that Hackaday has tracked since July. One commenter shared their experience. It's easier than I imagined, kind of like a fun puzzle due to the extreme limitations, but really well documented and clearly thought out so you can do a lot. The main debugging challenge. Everything's happening so fast that slowing the clock down 4x to follow along on a scope is useful.